Hello everyone, welcome back to my channel. Today we are delving into an essential topic in fluid mechanics and hydraulic machinery. Topic name is differential manometer. But before we jump into the fascinating subject, I kindly invite you to subscribe to my channel. Without any further delay, let us explore the topic. Differential manometers are the devices used for measuring the difference of pressure between 2 points in a pipe or in two different pipes. A differential manometer consists of a U-tube containing a heavy liquid whose two ends are connected to the points whose difference of pressure is to be measured. Most commonly used manometers are U-tube differential manometer and inverted U-tube differential manometer. In U-tube differential manometer, the pressure points will be at different levels and they will be at same level. Let us see in detail. The figure shows the 2 points A and B are at different levels and also contains liquids of different specific gravity. These points are connected to the U-tube differential manometer. Let A and B be the pressure and Y is the distance of center from B from the mercury level in the right limb, and X is the distance of center A from the mercury level in right limb, and rho 1 is the density and rho 2 is the density of liquid B, and rho G is the liquid of mercury, that is reference liquid. I repeat the terms: rho 1 density of liquid at A, rho 2 density of liquid at B, rho G density of liquid or mercury, PA is the pressure at A, PB is pressure at B, H is the difference of mercury level in U-tube, Y is the distance of the center of B from the mercury level in the right limb, X distance of center of A from the mercury level in the right limb. Now let us derive the equation. Taking reference line, that is datum line XX, and we can write the pressure in the left limb as so here rho 1 is the density of the liquid present in left limb into G into height. So that is X plus H, that is H plus X, and the pressure point. So here I am writing rho 1 G into H plus X plus PA. Similarly, write down for the right limb. So the pressure in the right limb. So pressure in the right limb is given by, as there are two liquids above the reference line. One is reference liquid, that is mercury, and another one is another liquid with uh, different density, that is rho 2. So that is rho G into H for mercury and rho 2 G into Y for different liquid plus pressure point. By equating the pressures, so we can write the equation, that is rho 1 G H plus X plus PA equals to rho G H plus rho 2 GY plus PB. And now this can be written as PA minus PB. Take out this term to the left side and take this term to the right side. So this can be written as rho 2 GH plus rho 2 GY minus rho 1 GH plus X. Now this can be written as rho GH plus rho 2 GY minus rho 1 GH minus rho 1 GX. Now taking the term GH as a common term in the first and third terms. So this can be written as GH into rho G minus rho 1 plus rho 2 ZY minus rho 1 GX. So the pressure difference between A and B can be given by GH into rho Z minus rho 1, rho Z minus rho 1 plus rho 2 ZY minus rho 1 GX. So PA minus PB, that is the pressure difference, can be calculated by using this equation. Pressure points are at different levels. Now let us see for the when they are at same level. The figure shows the 2 points A and B are at same level and contains the same liquid of density with rho 1 and rho 2. Now the pressure in the pressure above XX in the right limb can be calculated for the two liquids, that is rho G and rho 2. So let us write the equations. So that is rho G into gravity, that is G into height of the liquid, plus rho 2 G into height, that is here you can take it as X from the reference level to the center point of the B, plus pressure point. So this is for the right limb of the manometer, rho G GH plus rho 2 GX plus PB. Similarly, write for the left limb. Pressure above the XX in the left limb can be written as rho 1 G, height is X plus H. So this can be written as rho 1 G H plus X plus PA. By equating these two equations, we'll get like this: rho 2 GH plus rho 2 GX plus PB equals to rho 1 GH plus X plus PA. Now bring out the term PB to the right side, which can be written as PA minus PB equals to rho G GH plus rho 1 GX minus rho 1 GH plus X. Now this can be written as rho G GH plus rho 1 GX minus rho 1 GH minus rho 1 GX. So these two terms will get eliminated, that is, which can be GH into rho G minus rho 1. So PA minus PB can be calculated with the help of G into H rho G minus rho 1. Let us see a simple problem. A pipe contains an oil of specific gravity 0.9. A differential manometer connected at the 2 points A and B shows a difference in mercury level as 15 centimeters. Find the difference of pressure at the 2 points. First, the given data is specific gravity of oil, that is liquid, is S1 equals to 0.9, where density can be calculated with the help of 0.9 into 1000, which gives 900 kg per meter cube. 900 kg per meter cube. And the difference of the height is given as 15 centimeters. So H equals to 15 centimeters, which can be written as 0.15 meters. And next, the specific gravity of the mercury. So as the heavy liquid is mercury. So S2 equals to 13.6. Then rho 2 equals to 13.6 into 1000 kg per meter cube. Kg per meter cube. Now to calculate the pressure difference between the 2 points, PA minus PB is given by GH into rho G minus rho 1. So G value is 9.81 and height is 0.15 and rho Z is 13.6 into 1000, which can be written as 13,600 minus 900, which gives 18,688 Newton per meter square. Now let us see about inverted U-tube differential manometer. The inverted U-tube differential manometer consists of an inverted U-tube containing a light liquid. The two ends of the tube are connected to the points whose different pressure is to be measured, and it is used for measuring the difference of low pressures only. And the figure shows the inverted U-tube differential manometer connected to the 2 points A and B. So here H1 is height of the liquid in the left limb. So H2 is the height of the liquid in right limb, and H is the difference of light liquid in the left limb. H is the difference of light liquid, and rho 1 is the density of liquid at A, rho 2 is density of liquid at B, rho 3 is density of light liquid, PA is pressure at A, PB is pressure at B. Now, by taking the X as a reference line, that is datum line, the pressure in the left limb below the XX, the pressure in the left limb below the XX is given by PA minus rho 1 G and height is H1. So by taking the datum line at XX, then the pressure in the left limb is given by PA minus rho 1 G H1. Similarly, pressure in the right limb below XX will be given by PB rho 2 G H2. So that is the liquid B, and rho S into G into H. That is for the light liquid. Now, by equating these two equations, so if you assume this as 1 and this as 2, by equating 1 and 2, that is pressure above the XX in the left limb is equals to pressure above the XX in the right limb. We'll get the equation like this, and take the terms PA and PB to one side. So that is PA minus PB equals to rho 1 G H1 minus rho 2 G H2 minus rho S G into H. So the pressure difference between the 2 points will be calculated with this equation. Now let us see a simple problem. Find out the differential reading H of an inverted U-tube manometer containing oil of specific gravity 0.7 as the manometric fluid when connected across pipes A and B as shown in figure. Conveying liquids of specific gravity 1.2 and 1 at immiscible with manometric fluid. Pipes A and B are located at the same level, and assume that pressures at A and B to be equal. Now write down the given data. So the figure shows the arrangement. Now by taking the X as a datum line, and PA equals to pressure at A, PA equals to pressure at A, PB equals to pressure at B. Now density of liquid in pipe A, density of liquid in pipe A, that is specific gravity into 1000. So here the specific gravity is 1.2 into 1000, which gives 1200 kg per meter square. Now liquid density of liquid in pipe B. Similarly, specific gravity into 1000, that is 1 into 1000, which gives 1000 kg per meter square. Next, density of oil, that is light liquid, is 0.7. So specific gravity of light liquid into 1000, which gives 0.7 into 1000, that is 700 kg per meter cube. Now, taking XX as a reference line, the pressure in the left limb can be written as PA minus 1200 into 9.81 into 0.3, that is height which has been converted from centimeters to meters, minus 700 into 9.81 into h, where we need to calculate the height. Similarly, in the right limb, so previously we have written for left limb, now for right limb. So that is PB minus 1000 into 9.81 into h plus 0.3. h plus 0.3. Now, by equating two pressures, so that is left limb is equals to right limb, we can write the equations as PA minus 1200 into 9.81 into 0.3 minus 700 into 9.81 into h equals to PB minus 1000 into 9.81 into h plus 0.3. As we know that the pressures at A and B are equal, so PA and PB will get cancelled, and the remaining equation is minus 1200 into 9.81 into 0.3 minus 700 into 9.81 into h equals to minus 1000 into 9.81 h plus 0.3. Now divide the equation with 1000 into 9.81 on both sides. So the remaining equation will get as minus 1.2 into 0.3 minus 0.7h equals to h plus 0.3, that is minus h. So this can be written as 0.3 into 1.2 plus 0.7h equals to h plus 0.3. So by doing the calculation, that is h equals to 0.36 minus 0.30 divided by 0.30 equals to 0.06 divided by 0.3 meters, that is 1 by 5 meters, or it can be written as 20 centimeters. Finally, I thank for tuning into this exploration of the differential manometer. I hope you found this video both informative and engaging. If you have any questions or topics you would like to be covered in future videos, feel free to leave them in comment section or drop an email to drawingforengineers@gmail.com. Until next time, keep learning, keep exploring. Thank you.